Welcome back to the deep dive. You know, when you think about the rainforest, you get these images, right?
Oh, yeah.
Lush, endless green, maybe some mist, you hear exotic birds. But today, we want to cut right through all of that.
All the cliches.
Exactly. Our mission here is to get past the surface and really uncover the precise science and, maybe more importantly, the urgent geopolitics that are defining these ecosystems. We've pulled together a really great stack of sources to explore all of it.
Yeah, from the hidden chemical labs and the plants to the architecture of the forest itself.
A vertical world.
And we have to jump right into the deep end here because
Yeah.
the context is, frankly, one of profound crisis.
The seats are incredibly high.
Staggering.
Yeah.
Our sources are estimating that tens of thousands of acres of rainforest are being destroyed every single day. And look, this isn't just about losing pretty scenery. These places are biodiversity hotspots. They hold over half the world's plant and animal species on just a tiny fraction of the land area.
That concentration of life makes them, well, non-negotiable for the planet's health.
Absolutely.
And that concentration is exactly why we need to start with some basic definitions. Because when we say rainforest, we're talking about something very specific. A forest with a closed, continuous tree canopy, super high moisture levels, and this is a key factor, no wildfire.
And most people, they just picture the tropical ones,
Right.
Near the equator, warm, incredibly wet.
But that's not the whole story.
Not at all. You've also got temperate rainforests. You find those in cooler coastal places like parts of the Pacific Northwest or, say, southern Chile.
And then there are the ones you hear about less often, the dry rainforests.
Exactly. They survive with less rainfall, somewhere between 630 and 1,100 millimeters a year. But they still keep that essential closed canopy structure.
But no matter which type we're talking about, these ecosystems have always been seen as having this direct value to us. We call them the jewels of the earth.
And, they're often called the world's largest pharmacy. And the data, it really backs that up. I mean, something like over a quarter of all natural medicines we use, they were first discovered and derived from compounds found right there.
That immediate usefulness is a huge part of why saving them is so critical.
For sure.
But before we get into that pharmaceutical angle, we have to tackle I think the most pervasive piece of misinformation out there about rainforests.
Oh, the big one.
The big one. For decades, we've all heard that the Amazon is the lungs of the planet.
Exactly,
Yeah.
that it provides most of our oxygen.
Yeah, that's the story we all grew up with.
Well, that narrative, it's powerful, but it is, scientifically speaking, just not accurate.
Right.
It's really time we put that myth to rest.
Okay.
Yes, these forests carry out a massive amount of photosynthesis, about a third of all photosynthesis on land. But the net oxygen they add to the global atmosphere is, well, it's basically zero.
Wait, zero? That really challenges the story a lot of us learned. If the plants are making all this oxygen, why isn't it ending up in the air?
It's all about consumption. Almost all the oxygen produced gets consumed right back inside the same ecosystem.
Oh.
Well, about half is used by the plant itself during respiration, just like we breathe. And the other half gets used up by this huge army of microbes and fungi that are responsible for decomposition.
Breaking down dead leaves, wood, all that stuff.
Exactly. It's this beautifully efficient, almost a perfect closed loop.
So the oxygen they make is immediately used up by the forest community itself. If that's the case, then where does the oxygen we're breathing come from?
It's the ocean. The oxygen we breathe comes primarily from the ocean.
Okay, so what's the mechanism there?
It's actually fascinatingly simple. You have these tiny phytoplankton that photosynthesize and release oxygen. When they die, some of that organic matter sinks deep, deep into the sea.
And it doesn't decompose?
Not all of it. If it gets buried in the mud at the bottom before it can decompose, the carbon it holds is trapped, and the oxygen it produces stays free in the atmosphere.
So over millions of years, that tiny imbalance burying carbon in sea mud is what gave us our oxygen-rich atmosphere.
That's it.
That just flips the whole narrative on its head. It means that while the forests are absolutely essential, it's not for the reason we thought.
Precisely. Their real value is in climate regulation. They're these colossal carbon storage tanks. They stabilize weather, water cycles, and of course they maintain that mind-boggling biodiversity we mentioned.
They're vital, just not for the reason the old science books told us.
Right.
Okay, so let's move from that broad idea to the actual physical structure, because this isn't just one big green sprawl. A tropical rainforest is more like a huge multi-level high-rise.
That's a great way to put it. It's like a biological apartment building. and life is zoned into 4 distinct vertical layers.
And understanding these layers is, well, it's key to understanding the animals that live there.
Yeah, it's the difference between living in the basement and living in the penthouse. So let's start at the bottom. You have the forest floor.
Which is super dark, right?
Very dark. Because of all the foliage above, it gets maybe 2% of the available sunlight.
Yeah.
It's warm, incredibly humid, and all of that fuels just extremely rapid decay. Nutrients get cycled back into the soil almost instantly.
Right. And moving up a bit.
You enter the understory layer.
Yeah.
This gets a little more light, maybe 5%. The plants here, shrubs, younger trees, they've adapted by growing these much larger leaves.
To catch as much of that sparse light as possible.
Exactly. It's also home to a huge density of insect life, and naturally the things that eat them.
And then you hit the main event.
Then you hit the powerhouse, the canopy layer. This is the dense, continuous roof of the forest, anywhere from, say, 30 to 45 meters high. This is where the overwhelming majority of photosynthesis happens.
It's like an aerial city.
It is. By some estimates, this single layer might house 50% of all plant species. It is the most intense pocket of biodiversity on the planet.
And then way up top.
Finally, sticking up above that roof line, you have the giants of the emergent layer, just these individual massive trees that can reach 70, sometimes even 80 meters.
Wow, they must have to be incredibly tough to survive up there.
Oh, unbelievably robust. They have to withstand intense heat and strong winds that never even touch those lower levels.
What's so fascinating is how different animals divide themselves up among these layers.
It is. We looked at this big meta-analysis on vertebrate stratification, and the data, it shows these really distinct patterns depending on the animal.
So let's start at the bottom. What about the smaller animals, the ones that are less mobile?
For amphibians and small mammals, the pattern is just overwhelming. Their numbers and their species richness, they decline sharply as you move up toward the canopy.
They are very much ground skewed.
Heavily. And this is tied directly to the environment. I mean, think about an amphibian. They're ectotherms. Their body temperature depends on their surroundings.
So they need that moisture.
They need those moist, stable conditions on the forest floor to survive. They have a very limited tolerance for drying out, which is a huge risk up in the sun-drenched canopy.
That makes perfect sense for a frog. But what about the animals that can fly? Like bats and birds. They can navigate all 4 layers.
Right, so for bats, the data shows their numbers tend to be weighted toward the canopy.
More food up there, I'd imagine.
Abundant fruit, tons of insects at night. But some localized studies suggest that to avoid certain predators, like raptors that hunt in the canopy, they'll often come down and travel closer to the ground when they're foraging.
And birds, are they all just living up in the canopy?
That's what you'd think, but surprisingly, no. The patterns for birds were highly variable across the different studies.
So it's not a clear-cut case.
Not at all. Roughly half the studies in the analysis showed that richness and abundance increased toward the canopy, which makes sense, but the other half showed a decrease.
So there's no single rule for them.
No. It suggests that for birds, very local factors, like the exact density of foliage or where the fruit is, that stuff overrides the general 4-layer structure.
So to sum it up, life organizes itself vertically based on, well, the physical structure, where the food is, and for vulnerable creatures like amphibians, that crucial climate gradient that stops them from drying out.
Exactly. This complex vertical layering is how the rainforest maximizes its space, allowing this huge number of species to coexist by basically partitioning resources by height.
Okay, we've seen how life separates vertically. Now let's look at how they compete chemically. All this biodiversity leads to a kind of constant chemical arms race.
And that leads us directly back to the forest being the world's pharmacy.
That's a perfect way to frame it.
Down in the understory and on the floor, plants are under constant attack from pathogens, pests, fungi. Since they can't run away, they develop these incredibly sophisticated chemical defenses. Phytochemicals, or secondary metabolites. And scientists spend years bioprospecting for these compounds.
And what are the main chemical classes that have given us the most important medicines?
We can break them into 3 big groups. First, you have the alkaloids. These are nitrogen-containing compounds.
And they have powerful effects on us.
Potent physiological effects. This group includes quinine, the essential treatment for malaria, and even common stuff like caffeine.
But then you have the compounds that are now kind of buzzwords in the health world.
Right, those would be the polyphenols. This group includes things like flavonoids and tannins. They're known for their powerful antioxidant properties.
Which are linked to reducing inflammation and protecting against things like heart disease.
Exactly. And finally, you have the terpenes. These are what create the distinctive scents and flavors of plants. Think of the smell of pine from pine or citrus from lemon. Huge potential in medicine and perfumery.
And it's hard to overstate the impact of this. I mean, the sources remind us of major cancer therapies like vincristine, which came from the periwinkle plant.
Or even something as common as aspirin, which was originally based on compounds found in willow bark. It all has its roots in this botanical chemistry.
The potential is, well, it seems limitless, but this bioprospecting, it raises some really big ethical challenges.
Huge challenges, and they have to be addressed up front. Any search for these compounds has to prioritize conservation, and critically, it has to respect the intellectual property rights of indigenous communities.
Who hold that traditional knowledge.
Exactly. They often hold centuries of knowledge about the uses of these plants, and their role has to be respected to avoid, well, historical patterns of exploitation.
These challenges just underscore the urgency. We can't talk about the scientific value of rainforests without facing the brutal reality of their disappearance.
And our sources, they emphasize this terrifying loss. In 2024 alone, the tropics lost a record-breaking 6.7 million hectares of primary rainforest.
That crisis is cataloged by the IUCN Red List, which defines the threat levels, and I think it's helpful to know what these terms actually mean.
Right, so you have the vulnerable category. That means a high risk of extinction in the wild. Think of species like the clouded leopard or the hyacinth macaw.
Then you move up a level to endangered,
which means a very high risk of extinction. This is where you find the Indian pangolin, which we'll come back to, and the very vibrant sky blue poison dart frog.
And then the most dire status.
Critically endangered, and extremely high risk of extinction in the wild. This includes some of the most iconic creatures on Earth. The western lowland gorilla, the Sumatran rhino, and the African forest elephant.
Let's just spend a moment on the Sumatran rhinoceros. It's the smallest living rhino, the only Asian rhino with 2 horns. And the tragedy is just its extreme rarity. Experts estimate there are no more than 30 left in the wild. 30. Confined only to Indonesia.
And their populations are so small and fragmented, breeding is almost impossible without human help.
Then you have the African forest elephant. It's smaller than its savanna cousins, highly specialized for the forest.
And they're these mega gardeners. They eat fruits and then disperse the seeds over huge distances in their dung. Their disappearance has profound ripple effects.
And then there's the western lowland gorilla, with numbers dropping, partly because of the Ebola virus, on top of habitat loss.
And the Indian pangolin, often called the world's most trafficked mammal.
Hunted for its scales and meat. And its only defense is to roll up into a ball. These animals are just being squeezed from all sides.
So the question becomes, how do we move beyond just listing endangered species and actually implement effective policies?
And the policy debate seems to have really shifted toward leveraging local expertise.
Specifically, indigenous land rights.
And the data we looked at supporting this is, well, it's overwhelming. We examined a study on indigenous land tenure in the Brazilian Amazon. What did it find?
The findings were definitive. Indigenous territories that have secure land tenure, they consistently saw higher secondary forest growth on previously deforested land.
Higher than neighboring areas.
Much higher. Secondary forest coverage grew 5% inside those protected lands during a study period.
5% growth sounds good, but what does that mean in real terms?
It means that within those indigenous territories, the forest regrowth was 23% greater than the growth rate measured just outside their borders.
23%? That's a huge difference.
It's a profound difference. It shows that empowering indigenous communities isn't just good human rights policy, it's also, unequivocally, the most effective environmental policy.
And that's backed up by how well they protect existing forests too, right?
Absolutely. Indigenous territories have some of the healthiest forests in the Amazon. Only 1.6% of all deforestation in Brazil between 1990 and 2020 happened on these lands.
And this focus on restoration is supported by the fact that these secondary forests, they can bounce back pretty well.
They can. They recover an average of 88% of their species richness after about 40 years, which aligns with Brazil's pledge to restore 12 million hectares by 2030.
But there is an important counter-argument to this intense focus on restoration.
There is.
Some scientists argue that putting all this emphasis on regrowing secondary forests is a glorified detour.
And that's the necessary nuance here. They argue that putting too much political and financial capital into replanting distracts from the single most important issue,
Which is
stopping the destruction of the old-growth primary forests in the first place.
because you can't replace them.
You simply cannot replace centuries of complex primary biodiversity with a 40-year-old secondary forest, no matter how well it recovers. The number one priority has to be preventing that initial loss.
So after all this, what does it all mean for you? We went from, defining what a rainforest is and debunking that lungs of the earth myth to traveling through that complex, stratified, vertical world of its inhabitants.
We uncovered that staggering hidden chemical diversity, the alkaloids, the polyphenols, that made the rainforest the world's pharmacy.
And we looked at the harsh realities of endangerment for species like the pangolin and the critically endangered Sumatran rhino.
And finally, we reinforced the powerful, measurable benefits of indigenous stewardship in securing these vital ecosystems for the future.
So as you navigate the marketplace, you can look for the Rainforest Alliance seal. That little frog seal signifies products made by people and companies working together to find that crucial harmony between nature and people.
And we want to leave you with this one final thought. We talked about how organisms are specialized for different vertical strata, right?
Right.
Driven by food and climate.
Right.
Well, knowing that tropical soils are actually quite poor, with the nutrients concentrated right near the surface from decomposing leaves, what is the long-term impact of losing these highly specialized mega gardeners?
The African forest elephant or the Amazonian tapir?
The gardeners of the forest, known for their rich, seed-filled dung. What happens to the future structure and fertility of that delicate forest floor itself when they're gone?
Something to mull over as you consider the true complexity of this vital ecosystem.